So today's lesson is with word problems. All right. You're not only going to have to solve the word problem, but you're also going to have to set up an equation to solve that word problem. When you go to set up the equation, you can't set up the equation equal to X. All right. On your quiz on Wednesday, there will be multiple choice, and you'll have to pick out the correct equation. All right. From the multiple choice. When you go to set up an equation, you want to think about the opposite operation to set up the equation. If you think about a normal adding question, a normal one-step adding, normally always in one-step equations, you always do the opposite operation. So in a one-step adding question, you would have to subtract. You would have to subtract in order to solve it, because we would do -5 and -5, and then you end up subtracting the two numbers to get your answer. In a one-step subtracting question, you end up adding to solve, because we would add 6 and add 6, so you end up doing this adding here. So when you take a look at an equation, if you think that you're going to subtract to solve it, you would have to set up a one-step adding equation. If you think you're going to have to add to solve it, you're going to have to set up a one-step subtracting equation. Multiplying and dividing are opposites also. This is a one-step multiplying equation, so you're going to have to divide to solve it, because we would end up doing divide by 4, so we end up dividing to solve it. And then we have multiplying here. This is a one-step dividing question. We end up multiplying to solve it. So again, you have to think about the opposite, all right? You have to think, if I was just solving the word problem, what operation would I do to actually solve it? And then you got to think opposite. Well, two-step equations are a little bit different. With two-step equations, these are what the two different kinds of two-step equations look like. Sometimes you have multiplying at the beginning, sometimes you have dividing at the beginning, and then sometimes you have adding, sometimes you have subtracting. So it all depends on the individual situation. All right, it all depends on the individual situation. When we would go to solve these, if this was a plus sign here, in order to solve it, we would have to subtract. And then if it's dividing, multiplying, we would have to divide to solve it. This one would be adding and then multiplying to solve it. But there's all different combinations of things. So let's take a look at some of these. When I put this up on the board, I really want you to think inside your head, what operation, if I just said solve it, all right, if I'm not even talking about setting up an equation, if I just said to solve it, I want you to think, what operation, add, subtract, multiply, or divide, would I do to actually solve this? So it says Kim was given $16 for washing the car. She now has $20.33 in her piggy bank. How much money did she have before washing the car? So think inside your head. If I just said to solve it, would you add, subtract, multiply, or divide those two numbers? So normally what you would do is, she was given $16, she now has $20.33. What you would normally do is subtract to solve it. So you want to actually set up a one-step adding equation. You always want to set up the opposite. So you have the money that she had before she started. She was given $16, and now she has $20.33. So this would be the one-step adding equation that you would have to set up, because we said normally you would subtract to solve to figure out how much she had before she got the $16. So this would be the equation that you would set up, and then you would go through and solve it. So we would get X equals $4.33. So before she washed the car, she had $4.33. You add in your $16. So she had $4.33. You're adding in your $16, and now she has $20.33. Hopefully you see how that works. Again, I knew that I wanted to subtract the two numbers, so I set up a one-step adding equation. In the next one, a yellow shirt costs $5 less than a blue shirt. The yellow shirt costs $12.95. How much is the blue shirt? So think inside your head, would I add, subtract, multiply, or divide to normally solve it? So a yellow shirt, you have the yellow shirt costs. The yellow shirt is $5 less than the blue shirt. So the blue shirt is going to be more. So normally what you would do to solve it is normally you would add together those two numbers, all right? So because you would normally add, you want to set up a one-step subtracting equation. So x minus $5 equals $12.95. You have the blue shirt cost minus the $5 because the yellow shirt costs less, and that gives you that yellow shirt price. So when we would go to solve it, you would add $5 to each one, and you get $17.95. We said normally you would add to solve it. That's why we set up a one-step subtracting question. A teacher bought 5 calculators for $12.32 a piece. How much did he spend in total? So a teacher bought 5 calculators and each one was $12.32. How much did he spend in total? Well, normally what you would do to solve this would be to multiply these two numbers together. Remember, since we want to multiply in order to solve it, we have to set up a one-step dividing equation. The opposite of multiplying is dividing. So we could set up x divided by 5 equals $12.32. Or in this one, there's actually 2 different ways to do this one. X divided by $12.32 equals 5. Because when we would go to solve this, you would have to multiply by 5 and multiply by 5, or multiply by $12.32 and multiply by $12.32. Either way, you're going to be multiplying and multiplying 5 times $12.32. You have to do that opposite operation. Either way that you do it, you get $61.60. So 5 calculators, $12.32 each. You have to multiply those two together. You get $61.60. Cody bought 8 toy cars for a total of $60.96. How much did each toy car cost? So there's 8 toy cars. Anytime, one of the strategies that I like to use, anytime there's a word of a number, I like to sort of put the actual number there. It makes it easier to look at. How much did each toy car cost? Well, if he spent a total of $60.96 and he bought 8 items, normally you would divide to solve it. Well, because you would normally divide to solve it, we want to set up a one-step multiplying equation. So we have 8x equals $60.96. Because when we go to solve it, we would divide by 8 and divide by 8, top divided by bottom. You get that each toy car costs $7.62. So because we wanted to divide the two numbers to solve the problem, we had to set up a one-step multiplying equation. So that's what you do with one-step equations. Two-step equations are a little bit different. Now, remember, what we're looking at in two-step equations, we're looking to set up equations that look like this, like 2x plus 1 equals 6. That could be a plus or a minus, or else we have dividing and then plus or minus. So we're looking to set up a two-step equation in these next ones. So Emily spent half of her weekly allowance at the movies. To earn more money, she cleaned her parents' windows of the house for $5. What is her weekly allowance if she ended with $8? So just take a second and really think about what we're doing here. She's spending half of her weekly allowance. Well, let's talk about that word half. If we're going to take half of something, there's really 2 different ways that we could write it. To take half of something, you could divide it by 2. All right, if we take a number and divide it by 2, we're taking half of it. A different way that we could take half of it would be to multiply by 0.5. All right, we could multiply by 0.5. So those are two different ways that we could take half of it. Now 0.5, if you're thinking, well, we could also do 1/2 times x, that's the same thing as 0.5. I think 0.5 is easier to look at. So we're doing that, plus she earned more money. She earned more money by cleaning the windows of the house for $5. So we're taking half of her weekly allowance, which is what these represent. We're adding $5 to it for cleaning the windows, and she's ending up with $8 at the end of the week. So equals 8 at the end. So there are two different answers here that both get you the same thing. Because when we go to solve it, we would do -5 minus 5. So x divided by 2 equals 3, times 2 times 2, x equals 6. Over here, we would get the same answer, -5 minus 5. So 0.5x equals 3. Divide by 0.5, divide by 0.5, x equals 6 again. So that's her weekly allowance she starts off with each week. She's taking half of that and at the movies. So maybe she's buying candy or something. So she's taking half of it. And then she's earning an extra $5. That's where the +5 came from. She's ending the week with $8. Our final one, this is a classic question. A taxi cab charges a fee of $3 plus 0.25, so 25 cents a mile. If the total cab fare was $7.75, how many miles did they travel? So just go word by word. Just for getting into the cab, there is a seating fee, all right? Whether you go 0 mile or whether you go 0.1 miles or whether you go 100 miles, you have to pay $3 just to get inside the cab. Then we're paying an extra 25 cents for every mile that you go. So 25 cents times the number of miles. If the total cab fare was $7.75, so equals $7.75, how far did they travel? So this would be your equation in this one. We have the seating fee plus 25 cents times the number of miles equals $7.75. So we would go to solve it. -3 minus 3. So 0.25x equals 475. Divide by 0.25, divide by 0.25, and we get that x equals 19. So the taxi cab drove 19 miles. Again, the hard thing is setting up the equations. All right, the hard thing is setting up the equations. When you think about the equations, you have to think about the opposite operation, right? You have to think about the opposite operation. If it's going to be a one-step equation, it's going to look like these. Think how you would just normally solve it. If I just said solve the equation, think about how you would normally solve it. If you would normally subtract to solve it, you're going to set up a one-step adding equation like this equation in the black. If you would normally add to solve it, you're going to set up a one-step subtracting equation, because when you actually do those, you do those operations. If you would normally divide to solve it, you're going to set up a one-step multiplying. If you would normally multiply to solve it, you would set up a one-step dividing. With the two-step, you go more word by word.